this is Anugrahara. Welcome to the 50th episode of Microsoft Art of Code, brought to you by Millionlights. Millionlights is a TV channel dedicated to improving skills of people and their employability. Now, let me tell you more about Microsoft Art of Code. Microsoft Art of Code is a series of lectures, courses, and talks by experts who are going to discuss the latest Microsoft technologies, topics related to programming, and industry forecasts that are all focused on employability. This course is basically for people pursuing computer science. This content has been created by our partner Microsoft, and today we have Christopher Harrison and Gabrielle with us who will teach you everything you need to upgrade your skills. The topic includes in this course are getting started with JavaScript, object-oriented programming in JavaScript, web workers, server communication, JavaScript libraries. Now, let's move towards the course. In the previous episode, we covered the course Building Responsive UI with Bootstrap. In this episode, we will start with another course, which is JavaScript for experienced people. So let's get started.
All right, well, good morning, good afternoon, good evening, depending on where in the world that you happen to be. This is JavaScript for experienced developers. We'll talk a little bit about the course in just a moment, but first up, I'm very happy today to be joined by Gabby. So Gabby, why don't you go ahead and introduce yourself?
Hello, everyone. My name is Gabrielle Krefker. I am actually the newest addition to the field team of technical evangelists at Microsoft. I am from Florida State University, go Noles, and this is really a big opportunity for me. I'm really excited to be here and be with you all today.
And you can also find her on Twitter using the exact same No Way She codes.
Yes.
And definitely go check out her blog. As for me, I'm Christopher Harrison. I'm a senior content developer here with Microsoft, specifically Microsoft Learning, with a web development focus, really kind of full stack, front end, back end, really a lot of ASP.NET. I blog periodically at blog.geektrainer.com, and beyond that, I'm a marathoner, a husband, and a father of a four-legged child. So. Yeah, there you have it. Now, let's talk a little bit about you, since now that you know a little bit about us. The goal of the course here, sort of the impetus for this, is if you've done other programming languages like C# or Java, and you're taking a look at JavaScript, it is like just different enough, I think, to be confusing. Is about the easiest way to describe it. That you take a look at it and go, wait a minute, where's a class keyword? And you're going to notice very quickly that it's not there. Well, it's sort of there. It's actually reserved, but it doesn't actually work. But in any event, so that's really what the goal of this course is, so that we expect that you're coming to this just trying to get a little bit more about JavaScript, that you've done some coding inside of, say, Java or C# or maybe VB, and you're just starting to get into JavaScript. So that's really kind of the expectation that we have for all of you. The other real quick thing that we'd like to mention is about the community. MVA has a huge community, over 3 million registered users. You can go get your little MVA points. You'll notice down there at the very bottom, JS for EXPDEV. It expires on November 30th. And I would mention really quickly that that code is on the FAQ tab inside of the little window. So from there, let's go ahead and talk about the course. So what's Module 1 going to be about?
Okay, so Module 1 is really just really getting started with JavaScript. It'll be a review for some people, and then kind of a little bit of new topics. So we're going to talk about variables, functions, different type of functions, but kind of going more in depth and kind of exploring things that a lot of people don't know JavaScript can do with those basic concepts. And then topic 2 is object-oriented programming. So that's where we're going to kind of go into, okay, well, we don't really have the class keyword, but we do have this, this, and that. And this is how you can kind of do object-oriented programming with JavaScript. So it's not exactly the same as what you guys all may be used to, but there is a way, and we're going to show you how.
And it's sort of that same thing when we get into Module 3 with web workers, that there is this possibility of threading, although it's not typically what you would be used to. It's technically not truly threading, but it gives you the ability to simulate that. So we'll take a look at that with web workers. We'll then also take a look at how you can connect out to the server in a handful of different ways using things like WebSockets, using the XML HTTP request object, so that way you can make your pages truly interactive, truly dynamic. And then we'll close it all off with Module 5.
Module 5 is really just about the common libraries of JavaScript. So if you ever heard of jQuery, Require.js, Micro.js, and those are like the most that are really, really used a lot, and they're really, really handy. So we're going to go into those, kind of how to use them, import them into your HTML code and everything like that.
Yep, exactly. So with that, what do you say we go ahead and get started?
All right, let's get started.
Beautiful.
So now we're going to get right into it. So getting started with JavaScript. In this module, we're really just going to go over different types of functions, different types of notations, and kind of concepts that you guys all might know about, but don't really know the exact way to do it in JavaScript. So we're just going to dive right in there and get started.
That's the perfect way to do it.
So as we all know, JavaScript is the programming language of the web. It is used a lot, definitely with HTML, and it is known to have a lot of the basic syntax and language constructs that are very similar to Java and C++. However, once you go really deep and really delve into it, you'll notice there are a lot of differences that you can and cannot do with JavaScript that are a lot different than Java and C++. So pretty much just to get started, you really want to know how to get JavaScript onto your HTML code. Now, if you are kind of into JavaScript already, you do know there is now a way to use JavaScript in the back-end things. We're not going to get too much into Node.js, but if you are interested in it, there is a blog post on my blog at noishycodes.com, and it will tell you all about it. But getting back to it, what you would want to do to get JavaScript onto your HTML code is you need to use script tags. If you don't have script tags, you don't have JavaScript on your HTML code. It's just not going to work. So you can either A, have it right on the HTML code and simply just type whatever JavaScript code you want in between the two script tags, or you can B, use the same script tags, but you'll keep them empty in between, and you will import the location of the JavaScript file using the source keyword. So before we kind of get any further, you need to know that it is important to understand variables in JavaScript. I know it sounds like a basic concept, but they are a little bit different than Java and C++. So as we all know, most variables have a local scope, a global scope, and then a block scope. So local scope is very simple. You know, if it's a variable initialized inside of a function, it's only going to be able to work inside the function. Global scope, it can be used anywhere in the code, whether it's inside of a function, outside of a function, an if statement, anything like that. Then there's the block scope variables. So JavaScript does not have block scope variables. But just to go in depth with it, a block scope variable is pretty much any variable that is initialized inside of an if statement. So that doesn't exist in JavaScript. If you make a variable inside of an if statement, a switch statement, or anything like that, it is then considered global. So I'm just going to show you a really quick example of how this would go. So what I have here right now is we have the variable. So it's just a simple, okay, here's the color, it's blue. So inside the if statement, I've initialized a new color variable. And what happens is it's pretty much just overriding the original one. So now the color of the whole code is now purple instead of blue. And when you console log, which is pretty much like printing, for those who don't know, every time it's going to print purple instead of blue. Versus the next example, we kind of have now made color into a local variable. So we have color, the variable color, right at the beginning. Then we have it inside of a function. So inside of the function, when you console log the color, you will get blue. You'll get purple, I'm sorry. And then outside of the function, when you console log color, you will then get blue. So if you guys can see the difference there, once again, there's no such thing as block level scope. That's pretty much the main concept of what we're going into. So you either have local or global.
So local would be then for the function. So if I say function, declare a variable, it's scoped to just that. But if you're using something else like a while loop or an if statement, it's not going to be scoped to just that set of curly braces, which is obviously very different from any other language. That if I go in, I say if, and I declare a variable there, I get to that closing curly, it goes away. That doesn't happen in JavaScript.
No.
That can get confusing.
And then I guess also back into my other example, I had actually declared the variable color twice. And normally, since it's global, it might have caused like an error of some sort. But in JavaScript, actually, it won't do that. It'll simply just be the same variable. It won't give you any errors at all.
So you can just redeclare that variable a second time, and JavaScript just sort of makes this assumption of, well, you know what you're doing, I hope.
Yeah, so technically, yes, it's wrong, but JavaScript won't let you know about it.
Okay.
So next, I'd kind of like to step into functions and closures. So now we're going to go deeper now that you understand variables and how they work. So we all know what a function is. You know, we need it to do something, some type of functionality, just so we can help our code run better. We usually have different functions do different things and not have everything run globally. It's just not going to work. It's going to be a mess. So functions in JavaScript are pretty much the same as functions in other languages that you guys are familiar with. You know, you could have return statements, parameters, and things like that. The difference is when you are creating a function, you must have the function keyword. I repeat, you must have the function keyword. Without that, it's just not a function. No matter what you do, how you write it, it's just not a function. So what you would do is you pretty much start with the function keyword. You can give it parameters. You start with your curly braces, and you can insert whatever you would like. So I'm just going to do a quick demo just on a simple function that you could use. Okay.
And you're using Visual Studio Code here.
Yes.
So, which, if you don't mind my just jumping in for 2 seconds here, one of the things that I always like to mention is just the fact that with Visual Studio Code, you can actually run this on whatever OS it is that you want. So if you want to use Linux, if you want to use Mac OS, if you want to use Windows, you can use Visual Studio Code. And this will allow you to do web development with either ASP.NET or Node.js. And you can also, just as Gabby's about to do, obviously do HTML and JavaScript.
Yes. Okay, so let's get started with the demo. So I'm just going to declare a simple variable. As you know, variables do not have types in JavaScript, so you'll never have to put string or int. It's just variable. That's it. So I'm going to make a number. And from here, we're just going to make a simple function. So once again, the function keyword, and we're going to make a function that will find the square of any number. Oops. So have our curly braces. Oops, no, sorry. And then we're just going to return times x. Perfect. So now that we have that. So this is pretty much, we just made a function. And what you want to know is that functions can do different things in JavaScript that they can't necessarily do in object-oriented languages that you all may be familiar with. So what I'm about to show you is, as we know, you can always use a function and use its return value to give a variable a value. However, what you can do is you can combine a function return value with other values to create a whole variable. So I'm going to show you right now. So we're just going to create a quick little sentence. So the square of x is equal to, and then we just insert the function here. With the parameter of x. And then once we console log it.
And so console log will just write that out to the console, if you will, sort of like a console write line if you were doing a C#.
Yes.
Okay.
So once you console log it, it should then just print the whole sentence with that variable. So I'm going to quickly show you this. So right as I was speaking of before, I will be using Node to pretty much print this. So Node is the back end, I guess the back end version of a JavaScript. So you don't necessarily have to run your code onto, you don't have to run your code right onto a website. You can really just run it on a PowerShell or a command line and things like that. So, okay. Okay, and so the Node. So as you can see, can I do like a split screen here? Nope, it doesn't want to work. Okay, so as you can see, we have printed the square of x is equal to 9. So now what I'd also like to show you is, like I said, you could also declare a variable. So if we did variable num is equal to let's say 6, and then once again print it to the console. When you run it, it'll pretty much give you 36. So that is the same. JavaScript can do that also as far as giving the value of a variable to be the return value of a function. That's very simple, very easy. So we're going to move on.
Cool. So, and one little thing that I just wanted to mention real quickly there, you were using Node in the to go ahead and print everything out. One thing that's worth mentioning is, in order to use that, you do need to go install
Yes.
Node. So just fire up Bing, do a real quick search for Node, and then just go ahead and install it. It'll take all of like 2 minutes.
Yes, it's
But
really easy, really easy.
Yep.
So now we're actually going to move on to self-invoking functions. It's very simple. So the same way that, sorry about that. The same way.
Just get to the right slide.
Yeah, not sure what's going on here.
It happens to all of us.
Okay, so pretty much the same way you declare a function is with the function keyword, give it a name. So self-invoking functions are exactly what they sound like. They will run on their own. There's no need to call them. Pretty much you just declare a function and you put it within an extra set of parentheses and it'll automatically run. No ifs, no ands, no buts. So you never have to worry about that. So pretty much a lot of self-invoking functions are really good, especially if you want to do jQuery functions. So we're going to get more into jQuery a little bit later, but if you know anything about it, jQuery is pretty much a function that's used for a lot of animations or event handling. So with that, when you are doing your jQuery functions, if you need an animation to start right on the dot as soon as the page loads, that's great for a self-invoking function. Never have to worry about it.
And the great part about having that self-running function is that if you declare something inside of there, you don't have to worry about it potentially bubbling out and having a name conflict with something else.
Definitely.
Yep.
So with that, we're going to move on to enclosures. So an enclosure is very, very, very important. It's kind of like a nested function. So of course, we all know a nested function is a function within a function. And once again, a function is not a function if it doesn't have the function keyword. So once you put a function keyword inside of another function, you have automatically created an enclosure. So what's really cool about enclosures that most people don't know is its access to different variables. So it has access to its own variables, it has access to global variables, but it also has access to the variables of the outer functions. And there's no need to pass parameters through it. It could just use their variables with the same values and everything like that. So this is pretty much a small example I have on the screen. So what you see here is we have a show name function with an enclosure that's called make full name. And as you can see, the enclosure is returning a sentence using the parameters and the variables of the show name function. And once again, it didn't have any parameters passed through. So if you were to run this, it would perfectly print your name is Princess Gabby, which is me. I'm a princess, if you didn't know. So it's actually very unique how it works. And some fun facts that you want to know about enclosures is they do not actually store the value of the variables themselves. They actually store, sorry, I'm losing my words here. References. They actually store references to the variable. So this really helps when the variable values change. It will update inside of the enclosure. You never have to worry about recalling the enclosure or anything like that. And also another thing that's really, really awesome to me is when the outer function returns, you can actually still access and call the enclosure. So I'm going to show you a quick example of that, and we'll see how this works. Okay, So really quick, I'm just going to make a function. So we're going to go back to kind of like the name. So celebrity name. And we're only going to pass in a first name. So we're going to make a quick intro for whoever the celebrity is. And then we're going to make our enclosure. So we're just going to call it last name. So what we're about to do is we're going to pretty much show you how you can call the enclosure after the outer function actually returns. I remember the first time I did this, it actually kind of blew my mind because I was like, wow, that's really cool. So we're going to take the name intro and the first name parameter. And notice that we do not have a last name being passed into the outer function. So that's kind of where calling the enclosure after the outer function returns will come in. Sorry, you guys, if I'm a slow typer. Okay, and then we're just going to return the last name function. Awesome. So first, if you give, we just have regular my name because we're just going to pass in me because I'm famous. Right, you guys?
You are now.
So, Gabrielle. And then what happens is if you were just to call my name like this, the actual function will never run. The console log will never run. You'll never see this celebrity is Gabrielle. Why? Because there is no last name. So technically, the enclosure will never be invoked. It'll never be called. Now, simply if we just do my name, so the variable, and then add my last name, it's very complicated. It's French. Don't worry about pronouncing it. But pretty much when this happens, it'll then, this line right here is what invokes the last name enclosure, and then it'll run perfectly. So if you do this right, you do node. I'm sorry, please ignore the San Francisco and the Oakland. That's another example that I had up, but oops. But yes, so this celebrity is Gabrielle Krefker. Yeah, that's me. Hi, everybody. So I'm actually going to show you the other example that was supposed to print out the San Francisco and the Oakland. So really quick, we're just going to make another function, and we're just going to do it based off location. And this will also show not only calling the enclosure, but also it'll also show how the variables will update because they're references and not actual values. So let's get back to it. So we're going to do a city, and we're just going to say San Francisco because that's where I'm based. Yeah, go San Francisco. Okay, and then we're going to make a return enclosure with a get value.
So unlike before where you return just a function, now you're actually going to be returning an enclosure or essentially an object.
Yeah.
Okay.
Let's not talk about objects yet. We don't want to get
Okay,
too, we don't
right.
want to get too far. Do not want to do that and start confusing everybody. Okay, so we have a get function, and now we're going to make a set function. So the set function is pretty much just, of course, is exactly what it sounds like, you know, just changing the city variable. So even though it is happening in the enclosure, once again, since it has access to the outer functions variables, it will be changing the outer variable city, and then from there.
So that's sort of like a normal programming language, that if I have an outer set of curly braces and then I create something internal, and that might be, say, like an if statement, or in this case, we're creating an enclosure inside of an enclosure, the inner is going to have access to whatever's on the outside, just like that would be in pretty much any other language.
So here, you see that we are actually accessing the return enclosure by doing the myplace.get. So it's a simple little function within. And then we can also access the set function simply by just doing the same type of notation. And let's just change it to Oakland, because I like Oakland and I'm a Raiders fan. Okay.
I'm, of course, a Chargers fan, so I hate the Raiders.
Oh, wow. Awkward. This has got real awkward, you guys. So once you run this code, pretty much it should give you oh, where'd the code go? Okay. Sorry about that, guys. So you should then see how simply it just did a myplace.get and it was able to print out San Francisco by calling this function. And then shortly after that, we just set the city then to Oakland. And then once you did another get call, it was able to print out Oakland perfectly fine. So this pretty much is just showing you how you can call the enclosures, right after the location function has already returned. And it also shows how the variables are updated really quickly in enclosures.
So when I'm calling that function, it's giving me back the enclosure, and then I can call the couple of functions that you created on that enclosure.
Yes.
Okay, perfect.
Yes. So I keep losing my slides. All right, so quickly, we're just going to do a quick intro to jQuery. So I know I just mentioned them when we were speaking on self-invoking functions. So jQuery is really just, is really known to be the write less, do more JavaScript library. It is a JavaScript language per se, but it really has a lot of its own functions that pretty much take JavaScript functionality and make it a lot smaller. It's really easy to use, once again, and we're going to go really, really deep into that in Module 5, but here's just a quick little intro. So what I have here on the screen right now is pretty much just the syntax of jQuery. So once again, it needs to be written in between script tags, just like JavaScript. And if you're going to write it on an outer function, on an outer file, you simply just write it in a JavaScript file. It doesn't have its own like type or anything like that. So what we have here, the syntax, you always start your jQuery functions with a $sign. That's pretty much it. If it doesn't have a $sign, it's not jQuery at that point. It's just JavaScript, and then all this extra stuff really won't make any sense. And then from there, in the parentheses, you have your selectors. So your selectors are pretty much whatever HTML element you want to be manipulating at that moment. So here I've shown you the this selector, a p selector, and the test class selector. So the this selector is pretty much when you're having a jQuery function inside of HTML element as is. If you have the script outside of the HTML element, then you can just call it. So if you want to do all the paragraph elements, then as you see, you can easily just call the P. If you want to do it inside all the test class elements, then you would simply just do period test, and now we have called the class test. Same thing with ID. With IDs, of course, you started off by calling them with a $sign. So it would just be pound, whatever the name of the ID is. It's very simple. It's just the same way you would call the selector inside of a CSS file. If you call it that way in the CSS file, then you would call it the same way in jQuery, just in parentheses. And also here, right after you have the selector, then you have your dot notation, and you then have your action. So once again, jQuery has a lot of functions that are already done for you. So for example, this is the hide function. It's very, very easy. It is exactly what it sounds like. The hide function will pretty much hide this element from the page.
So real quick here, only just because somebody had asked the question and it sort of relates to jQuery, so I just want to answer this real quick. Somebody had asked about if we're going to be taking a look at ASP.NET Ajax. And the short answer to that question is no. The slightly longer answer is because ASP.NET Ajax really, I don't know if doesn't exist is the exact right phrasing, but it sort of doesn't exist.
Yeah.
That what wound up happening is development was going, and then jQuery became very, very, very popular. And rather than compete with jQuery, the decision was made just to go ahead and use jQuery. So all of those different things that you could do with ASP.NET Ajax, you can actually do with jQuery, and then some additional libraries that are available for jQuery. So for example, like jQuery UI or maybe bootstrap. So that if you're looking for some of the different things that ASP.NET Ajax would give you, like an accordion, you could get that with either jQuery UI, or you could get that with Bootstrap. So we won't be getting into ASP.NET Ajax because you're going to be using jQuery instead. So anyway, cool.
Okay, so moving on, we're now going to go into anonymous functions. So anonymous functions are pretty much exactly what they sound like. They don't have a name. So really, you would just have the function keyword, no name, and go into the rest of the syntax for a function. They're really good because there are actually a lot of reasons why you wouldn't need a function to have a name. And at first I was like, why would you need that? How are you going to call it? But there's actually a lot of instances where, why do I need to call this function? And so on and so forth. They're actually really used a lot in recursion and in enclosures. So really quick, here's an example. So at the top, we just have a regular named function. And then at the bottom, we have an example of where you would use an anonymous function. So you can give a variable, the value of a function. But it's like, well, if I'm going to give the variable the value of a function, why would I name that function? Exactly. That's why we have an anonymous function in this example. But they're pretty much doing the same thing. Now, the difference between these two examples is at the top, you are initializing, you are declaring a function. So even though it could be anywhere in the code, you can also call that function anywhere in the code, whether it's before it's declared or after. Now, with the variable, you cannot call that function until after the variable is initialized, or else the JavaScript's going to be really confused and be like, well, what are you talking about? Because it's not exactly a real function.
It's a variable.
Yes, it's a variable.
So all those same rules would apply.
Yeah.
Okay.
So I'm just going to show you some quick, really easy anonymous function examples. Okay. Whoops. So what we have here is at the top, first we just have a simple function expression. So what you see here is the variable that we discussed and then how you give it a function value. Simple, easy. Then what you can also do is have anonymous functions inside an object. So we haven't really gone too deep into objects, but as you know, when you have an object, you have many different properties of an object, and your properties can be variables or functions. So pretty much inside of the pony object, we have given it the property of a simple say the name of the pony, and we have given it a function. So it pretty much kind of is the same as the variable. Like, why would you give a function a name twice? It's pretty much how that goes. The next example is definitely just a regular event handler, a jQuery event handler. And once again, we'll go more in depth. But as we already described, we have the element, and this is the click function. Just like the hide function, there's a click function. So the click function is exactly what it sounds like. If you click a button or if you click a link, what happens? So this is how you pretty much give the click function whatever you want it to do, but you're not going to name the function click if it's already has the name click. And then lastly, self-invoking function. So we just talked about this, but if you really think about it, if the function is really just going itself, we don't really need to call it. Why name it? So that's pretty much it. Anonymous functions are really good in that sense that they're just good to go by themselves, and you really don't have to worry about anything you don't have to call again. That's what an anonymous function is great for.
Yep. Yeah, and then that way you can avoid the names and avoid the avoid having all the different noise there. The other real quick thing that you may have noticed on Gabby's code was that click equals function. If you're a C# developer, that's very similar to doing an event handler, where you would say whatever the event is plus equals, and then point at whatever your function is. So a similar syntax, but obviously the mechanism is slightly different in JavaScript. That you're actually just taking the function and putting that onto that click property. So, yep.
Okay, and then what I was telling you about before is how well anonymous functions are used definitely for recursion. So what we have here in this example is we're going to do the factorial function, which is very well known to anybody who has done any type of coding in any way, in shape, or form. So what we have here is the variable factorial, and then we have the function. Now, I know you're wondering, okay, well, in a recursive function, you continuously call the same function, but how can you do that if it doesn't have a name? So what we have here is the arguments callee keyword, and that is the way pretty much of calling the anonymous function over and over again, and that is what is going to continue your recursive function. Inside of an enclosure, so sorry, I kind of just lost my thought. Sorry about that, guys. But we're just going to go back to the example that I kind of typed up before, where we had the location example. And as you can see, the get and set functions, once again, they don't have names, because what is the point of renaming the get and the set function? So that's also a good place to use anonymous functions, is inside the enclosures. And just like this, it kind of resembles, the object format that you just saw, which once again, we'll go really deep into. But it kind of resembles that. So instead of double naming functions, anonymous functions are great for this purpose. So next we're going to move on to errors and exceptions. It's actually fairly simple and actually very, very similar to a lot of other object-oriented languages. Not too much of a difference, but we're just going to quickly breeze over it. So in JavaScript, as usual, you can catch a lot of different types of errors. So there's logical, there's syntax, and there's runtime errors. And the methods we're just going to go over today are the try, catch, and finally statements, the throw statements, and the on error method. So try, catch, and finally are pretty much different blocks. So as you know, the try block is where you put the code to try. Now, if you put the code in there, that doesn't necessarily mean there's going to be an error. But if there is, it will pass the error to the catch statement. And the catch statement will simply execute some code as to what you want it to do when it does find an error. And then the finally block is just a good block if you, no matter what happens, you want something to print or you want your code to execute something, the finally block will always execute whether there is an error or not. Once again, whether there is an error or not, it will always, always, always run. It is also optional. You really don't need it if you have a try and a catch block. So it's just something to think about, and it also depends on what kind of code you're working on and what you're doing. Next is the throw statement. So throw statement is pretty much used for, customized exceptions. If you just want it to be like, hey, tell me that, I don't know, the pop-up window had the wrong words or the user typed in the wrong thing. So it's kind of just like that. It isn't really one that the code itself will catch, but more so one that you want to catch for yourself. And you can usually find the throw statement within the try and catch statements. So they're usually used around the same thing. So usually in the try or the catch, you could put them in either one. And then there's the on-error method, which I think is actually pretty cool. So the on-error method is actually an event handler. And what happens is you put it between two script tags, and it'll pretty much fire whenever there's an error. You never have to tell it to go, it just knows. And the unique thing about the on-error method is it is able to give you an error message, is able to tell you what file the error occurred in, and is able to tell you the line number in the code. Now, just because you have all this information doesn't mean you have to display it to yourself. You can manipulate the on-error method to only display what you want to see. So if you only want to see the error message or you only want to see the file, that's all you have to do is just simply manipulate some code and just say, hey, console log just this information, and that's it. So I'm just going to show you a quick demo. Like I said, try, catch, and finally and throw statements, they're all pretty much very unique and not unique, sorry, they're pretty much very common and known. So I'm not really going to type out anything, just pretty much show you a nice little layout of how it would go and things like that. So here we have a nice little HTML web page, which I'm actually going to show you, like execute it. But inside the script tags, we have the JavaScript, and we have a simple function that'll just pretty much, it's based off the number values of variable A and variable B. So we have our try statement right here that will just throw a simple error that, once again, only we just want to see, because clearly it's not really going to tell us that we're going to have a divide error if there's no actual division happening here. Just saying, hey, if B is equal to 0, there could be a divide by 0 error. And then we have our else statement. So if you continue, and then that's where the division will actually happen within the try. And then you have a catch if there is an error. So if anything does happen, it'll let us know. And then the finally block. So the finally block doesn't really say anything or isn't really functional in this case. It's really just to show you that it will always execute. So I'm just going to show you that first before I show you the on-air method.
And one real quick thing, and again, just sort of bubbling up from the Q&A, somebody had asked on the catch, because one of the things, of course, that you could do in, say, C# is you could say catch, and I want an IO exception, and then I want an exception. In JavaScript, we don't have that because it's not strongly typed, so it's just going to be the one catch block. Now, from there is a JavaScript type of command that you can use to detect the type, but then you would wind up building up either a switch statement or an if statement to detect the appropriate type. But it's only going to be that one catch.
Yes.
Yeah.
So moving on, I'm just going to quickly show you guys this. How did we get all the way here? Okay. So, yes. So here we just have the simple code that I read up. So what happens is when you click the button, what it's going to do is actually execute the JavaScript function. So click me. Oh no, this is awkward.
And allow block content real quick.
Okay. Ah, there we go. So, so as you see, C equals 10. And if you go back to, where's the code? The code, that's exactly what should happen. We have 100, we have 10. B was not equal to 0, so we simply just did, simple division, and then we did what C is equal to. Now, let's see what happens when you change B to 0. Okay. Oh, and as you see, the finally block will always execute no matter what. And then refresh the page. I think it refreshed. Okay. Click me. So now we have the divide by 0 error, which is pretty much what we put in the throw statement. And then once again, the finally block always executes. Now, if we go back, what you will see is down here, I actually have the on error function. So I'm just going to comment this out and uncomment this. So here is the simple on error function. So like I said, you can kind of use the parameters that it has. So that's the actual error message. That is the page where the error occurred, and that is the line number. And you can kind of manipulate how you want it to alert. So if I just took out the alert message, it will only show me the page and the line number. So let's see what happens when we have now took out the code. We've commented out the code. How will this page run? So refresh, click me. See, so now it says message, your my function is undefined. And then it says where, would be our page, and then it gives us our line number.
Perfect.
That's pretty much how the exception handling happens in JavaScript. So as you know, in this module, we kind of went over functions and objects, we went over anonymous functions, and we went over errors and exceptions with a little dabble into jQuery. You heard a little bit about Node and things like that. So.
Yeah. The only last little thing, just one last little question from the Q&A, and then we'll go ahead and wrap up this module. Somebody had asked, why you're doing the check for divide by 0 rather than just doing it in the try catch. And you could have just left it, you could have just caught it that way. But one of the little things about exception handling in general, just as a best practice, is if there is a way that you can detect it before the error actually occurs, you should do that, both for performance purposes, but also just because it gives you the ability to still maintain control, if you will, inside of your typical flow, rather than having everything bounce out to the catch. So, one of those little things that you can do is just do a real quick check rather than doing the exception. And in Gabby's example, in your example, what you wound up doing was just going in, doing the check, and then throwing it just so that way you could demo the catch. So in any event, with that, let's go ahead and wrap up this module. And then when we come back, we'll actually take a look at how we can do objects, sort of, inside of JavaScript. So we'll take 10. We'll see you back then. Welcome back to JavaScript for Experienced Developers. Alongside Gabby, I'm Christopher. I'm just going to avoid saying your last name.
That's fine. Totally fine.
But in any event, one real quick little note that I want to make before we roll on into the module. A couple of people have noticed that the schedule slide, in fact, I think that's the next slide that you have on your deck. You might notice that the naming there is slightly different than what's on the break slides. It's the exact same thing. I just used some slightly different verbiage when I was typing out the break slide. So that was all there was to it. So, but in any event, let's pick up where we left off. So in that last module, we took a look at how to set up enclosures and functions and get rolling down that path. And now we're going to talk about what JavaScript calls objects.
Well, let's get started. So as you said, we're kind of going to go into the object-oriented programming of JavaScript. It's not exactly everything you think it is, but it's kind of similar. So we'll be talking about creating objects, the dot and bracket notation, how it works, how to create constructors, prototypes, and inheritance and encapsulation, and how it works within JavaScript. So object-oriented programming in JavaScript is similar, you could say, to Java and C#. I actually have a big background in C++. That's what we learned when I was in college. So kind of learning how it works in JavaScript wasn't too hard, but there were a lot of things that were definitely different. So what makes JavaScript different is it pretty much supports inheritance through prototyping. And we're really going to go and see how to create prototypes and how it works, but it's pretty much just, you create a constructor, and with a constructor from there, you create different objects using the constructor. Sounds fairly simple. It is fairly simple. So no need to worry, but just remember there is no real class statement, no real class keyword. It doesn't exist, not here in JavaScript. It's all constructors. So as we talk about objects, JavaScript does have some built-in objects, but the object at the top of the hierarchy would be the object. So all objects that are made, whether built-in or customized, which is the ones that we would be making, they all pretty much inherit all the functionalities of the object. It's very important to keep in mind when we get really into prototyping and inheritance and things like that. So first, we're going to just jump right into creating an object. You kind of saw a little bit of the functionality in Module 1 and kind of how the syntax works. So we're just going to dive right in there and kind of show you the different ways. So there's two ways to creating an object. You can either do it the object literal way or using an object constructor. They'll give you the same pretty much result. One can be easier, one can be, I guess, more a bit time consuming, depending on who you are, what is your strategy, what you like. I'm just going to show you a quick demo on creating an object. So let's start with something that applies to some people, or maybe not a lot of people, I don't know. So we're just gonna do something like college-y, something maybe that just applies to me about a few months ago. So I'm just gonna make an object. This is gonna be called my grades, and I'm not gonna have any grades. So what we did here right now is we created an empty object, but it is identified as an object just simply because of the curly brackets. So let me make this bigger for you guys. Mm-hmm. 1 second.
And that's sometimes just known as JSON,
yes.
What you're about to do. Okay, JavaScript object notation. All the cool kids call it JSON.
Yes, that's what we call it, because I'm a cool kid. But that's pretty much that. So I'm going to give you another example. So let's say, we have the class college algebra. Whew, that was a great class. Yes, it was. So once again, we have our curly brackets, and we're just going to simply put the properties, declare the properties within the object. So we'll say the level of the class it's a freshman level. At least I took it freshman year, so hopefully everyone did. Then the difficulty of the class, we're going to say that it was a hard class, and then my expected grade.
And that's just simply key value pairs that you have there.
Yeah.
Okay.
And then just like classes in other object-oriented programming languages, you can also, give it variables, but you could also give it functionality. So we're just going to give it a quick little function. Let's say we have the textbook function, and the textbook function will just simply say, I guess, what kind of textbook is needed. So, you'll need, let's say, college algebra for freshmen is the required text. Cool.
So you're just adding a function now onto that object.
Yes, very simple. So what we did here, this would be, I believe, the object literal notation. So then the other notation, it's kind of simple, but pretty much, let's say we're going to make another one. It's going to be college algebra. We'll just call it college alg, just so you can see the difference. So once again, we'll make it into kind of an empty object, but what you can also do is you can call the object as we were speaking of before. So just say simply a new object. This is actually an example of what you'll see later when we're prototyping, making prototypes and then going into inheritance, because it's kind of how it would work. But let's continue adding properties to the college alg object. So simply you could just do college alg, and let's say you want to have a level property. So level equals, once again, freshman.
And so you're just grafting those properties right
Pretty much.
onto
We're just
there.
going to give it a level and just the same function, just so we're not like getting too too repetitive here. So just a textbook function. Whoops.
And sometimes while Gabby's typing away here, sometimes people like to call this duct typing, D-U-C-K, not like duct tape, which, as everybody knows, holds the universe together. There's an old joke, what do duct tape and the Force have in common? They both have a light side and a dark side. They both hold the universe together. But in any event, it's sometimes called duck typing. If it looks like a duck, walks like a duck, quacks like a duck, it's a duck. That you're just taking the object and you're just throwing on whatever it is that that you might want. And what's great about that is that it gives you some additional flexibility. So that way, if at runtime you realize that you need to just store something on an object, or if you just need to add some additional bit of functionality, you can do that just by adding on those properties. So in any event, it sounds like you've typed everything in there.
Yes. Okay, so this is pretty much how on the demo is pretty much how you would pretty much create an object. These are the two ways. Now, one thing you kind of want to know how to do, which is very important, is if you can console log an object, or just print it onto your command line. So if you just did college algebra, oops. So I'm going to quickly show you how that would print. And then you want to be able to, to call your textbook function. So if you're wondering how you would do that, it's just a simple college algebra dot textbook. Oop. Just like that. Fairly simple, fairly easy. And then I'm just going to also show, I guess, how the other objects would look, and just so you can really see that there really is no difference at all. Like none, absolutely none, by doing it either way. Okay. Oops. Did I do that right? I definitely did. Okay.
Yep, you're good.
Okay. So that's done. So let's just quickly go and run it. And then once again, we're using Node. So as you see, the top in brackets, this would be your college algebra object. So it says your level, it says your difficulty, expected grade. So pretty much the property and either the type or what it is. So as you see, the textbook doesn't say exactly which function, it more so just says that it is a function. And then this right here is when we called the textbook function from the college algebra, object. And this is also at the bottom, this would be the college alg object. But as you see, they're pretty much exactly the same. They have no difference. So either way you do it, you're going to be creating an object, whether it's object literal notation or you're declaring the properties outside of the actual object.
So both of those will create an object that you can use.
Yes,
Okay.
both of them. So both of these notations, this is really what's important here. And like I said before, right here, you're pretty much just calling the object constructor, but we'll definitely get more into that when we get into prototyping and inheritance and things of that such. So moving on, what you also need to notice is there's a dot notation and a bracket notation. So we use the dot notation when we were calling onto the different properties, either to call a textbook function in the college algebra object, or when we were adding properties to the college alg object. So the dot notation is fairly simple. It is exactly what you saw on the screen. The difference between the two is the bracket notation will let you access variables even if you've given them a different variable name. I know that sounds really confusing, but I should have a quick little example to show you the two. Oh, no, sorry. So pretty much if we just go back really quick to the demo. So as I said right here, this is dot notation that you see, all of this. Now, if you want, you could also do, you could, oh, sorry, I don't know how to do that. You could easily change it to, you could change it to, here's your bracket, and just say textbook. And it would do the same thing. So what I was saying is with the bracket notation, you can give it another name. If you were to do, let's say another property like variable, I'm just gonna call it I don't know because I really don't know what to call it, and make it equal to college alg textbook. When you come down here and you wanna console log it, if you simply change it, or sorry, just call it, if you just simply change it to console log, oops, this is all wrong, okay. Console log, college, I'm sorry, no, console log, and then just say, I don't know, it'll pretty much do the same thing. Or even if you do college alg, and then put I don't know into brackets, it would actually just still run the textbook function. So it's actually
Okay.
A bit different. That's something you could do with the bracket notation.
And so the bracket notation gives you the ability to be a bit more dynamic there. So if maybe at runtime, you're going to figure out what property it is that you want to display, you could then use the bracket notation there. Okay, cool.
Very, very easy. So next, simply deleting properties is just as easy as creating them. So there's a simple delete keyword. Once again, you can use bracket or dot notation. Either one will work. So if you created your college alg object and you gave it a level of difficulty and expected grade, once you call the delete keyword and then just simply do the dot notation to choose level, if you were to print the college alg object again, it will simply just print difficulty and expected grade. But however, you cannot delete properties that are inherited, which once again we'll go deep into inheritance further into this module. But if it's not an original variable or property of the object, it cannot be deleted.
That's all in this episode. I hope this tutorial was helpful. In the next episode, we will cover the remaining part of object-oriented programming in JavaScript. And after that, we will move towards web workers. Is your mind ringing with questions, queries, or doubts? Do you wish to learn more? Then visit our website www.millionlights.org and post your questions on our forum. We will be really happy to clear all your doubts. If you missed anything and want to rewatch it, you can download it from our website or can watch online as well. You can also participate in our webinars, discussions with the subject experts, as well as get Microsoft certification on various courses through our website. You can also find us on Facebook by the name Millionlights and also on Twitter. For more such interesting tutorials on coding, app development, and building rich UIs, keep watching Microsoft Hour of Code, brought to you by Millionlights. Thank you.